Welcome to qnawire.
In order to approach this problem, we need to look up what kind of equations we can use in order to solve problems involving stretching cord. So if you go to page 725 of the textbook, you should be able to see a list of equations. And among all of them, those two are the most relevant that we can potentially utilize to solve this question. So let's take a look at A first. In question A, we have two numbers. First is 50 Newton, and the second one is 20 centimeters. It's pretty obvious that we can see Hooke's law. The first equation involves both of the variables we have. So let's take a look here. F equals to k times delta x. Since we're looking for the spring constant k, we can convert this equation into k equals to F divided by delta x. And it's easy to tell that we have both of the variables in number here. F equals to 50 Newton and delta x equals to 20 centimeters. But be careful here that the unit of delta x needs to be in meter. So we need to convert 20 centimeters into 0.2 meters. And then we do the calculation here. K equals to 50 Newton divided by 0.2 centimeters, 0.2 meters. It's going to give us 250 Newton per meter. And that will be the answer of A. Now we can take a look at B. It asked us to test the result of A in another way, which means we need to utilize another equation in order to see if we get the right spring constant. So among all the equations on the page 725, the equation that involves T and also M and K is the most relevant one. So if we take a look here, T equals to 2 pi and this. So since we're, again, looking for K, it's going to give us, need to convert it into another form, which is K equals to 4 pi square times M, and then divide by T. So now we know that in order to know K from this equation, we need an M, mass of the object, and also a variable T, which is the interval of time that one vibration, one cycle would take. So in order to solve this problem, to see how we can test it, we need an object of known mass M. And you basically put it on a spring, the spring that we were calculating for in A. On the spring, attach the object and then pull it. And you basically need to time like how much time the object takes to finish one vibration. And once you have all the numbers, you plug it into this equation, the one we got here, and you should be getting an experimental K, and you need to compare it to the answer we got in A, and then you can see how, like, if we get the right answer.